of first order ordinary differential equation, from the notes, there are 5 types of first order differential equation that we're going to focus on. Okay, it's separable, homogeneous, exact, linear, and Bernoulli. All right, so there are actually more than 5 types of first order differential equation, but we are just focusing on these 5 types only. Okay, so the first one is separable equation. All right. So how can we identify the separable equation? Okay, it's quite easy to identify the separable equation, and this is the most simplest differential equation for first order ordinary differential equation. Okay, let's say you have a function of differential equation dy dx, where the function of differential is in terms of x and y. The function itself is in terms of x and y, or we can just write separated function of x and y. Okay, hence this become a separable equation if it can be written as this, where we can separate the function of y together with dy, a function of x together with dx. All right. So if we can separate the variable, if we can separate the variable of function x and y according to the differential, then we can call it as separable equation. Okay, so after you can separate the equation accordingly to the variable, then we can solve by integrating both sides. Okay, let's take a look at the example. Here we have dy dx equals to y cos x 1 plus 2y squared. Okay, we have dy dx equals to y cos x over 1 plus 2y squared. So now we need to separate the function first according to its differential. For y with dy, for x with dx. So now can we just separate this function? Can or cannot? What is the separated version from here? As you can see, this is for y, right? This is a function for y, and this is a function for x. So you just can separate this by moving the function. So this one should be with dy, then just put it to the right hand side. And this one should be with x, then just put it to the right hand side here. So just bring this to the left hand side, then you can have 1 plus 2y squared over y dy equals to cos x dx. Understand or not? Okay, so basically this is dy dx. This is a function in terms of x and y. So in terms of x and y, then we can separate this function according to its differential dy and dx. So just rearrange the function actually. So once you can have the separated function, then in order to find the solution of this separable equation, you just need to integrate both sides. Okay, so integrate one by one. Here we have what? Okay, can anyone integrate this for me? What should we have here?
Y plus y squared.
Okay, ln y plus y squared. So here you should have ln y plus y squared equals to integrate cos x sin x
Plus c.
plus vc. Okay, so in our last class we have done with order, degree, linearity, condition. Okay, another one is types of solution. So now if you have up to C here, we call it as general solution. Okay, but you are given a condition, so you need to find the particular solution. So for particular solution, you have to have the values of constant then. So how can we find the values of constant? Just use the condition given, where the condition given here is when x equals to 0, y equals to 1, because this is yx equals to 1. So x0, y1. So just substitute. Y is 1, x is 0, then you can find c, where c here equals to 1. So the particular solution should be ln y plus y squared equals to sin x plus 1. So this is how you solve separable equation. Is that clear, everyone?
Clear.
Okay. Anyone has question? Very easy, right? Okay. Let's take a look at the notes. Okay, in the notes, some DE, some differential equation, may not appear separable initially, but through appropriate substitution, the DE can be separable. Okay, for this case, directly you can separate the function, but somehow at a certain function, we cannot separate the function directly. We need to use substitution. Okay. Right, so before we proceed, let's try to rewrite the following functions into separable function. Okay, let's try A, B, C, and D. Okay, anyone want to volunteer? Just separate the function so that we can see this function can be separated directly or not. Okay, anyone? Okay, come on, anyone? We have how many participants? We have 57 participants. All right. So this is only 4 questions. Okay, any 4 of you? Come on.
Doctor,
Yes.
I try the A.
All right. May I know who's speaking here?
Irshad.
Okay.
So for the A, we can separate directly, and the answer will be 1 over sec square y dy equal 1 over 1 plus x square dx.
Okay, all right, correct. Okay, the next one. Thank you, Ishad.
Dr. I will try for the B.
All right.
Yeah, so for B, supposed to dt equals to 1 over s minus s squared ds.
Which part? B or C?
B. C, sorry.
C. Okay, again.
Dt
dt
equal to 1 over s minus s squared.
1 over x
X
minus
minus s squared.
square.
Then
Yeah.
ds.
All right. Okay. Or you just can change this position, right? Because dt is the independent variable. So for the independent variable, at the end of the process, we just can plus the constant, right? Remember, we plus the constant here with independent. So better you put the independent variable in the right one. But it is correct. Okay. Right, then the next one. B.
3v over 1 minus 4v squared dv equals to 1 over x dx.
Okay, good.
Or
This
B.
is just quite identical with the previous example, right? Okay. B equals to 1 over x dx. Okay, the last one.
1 over 1 plus y squared dy equals to 3x squared dx.
All right, so this is how you separate the function directly. I hope you can try E and F here. Okay, it can be separated, but it takes quite a process before you can just directly separate. Okay, so this is how you separate a function in order to proceed with solving the differential equation, specifically for separable equation. Okay, now let's try example 2 where the differential equation cannot be separated at first, but by using the right substitution, we can solve this by separable equation. Okay. So now let's try example 2. Show that dy dx equals to x plus y squared can be reduced to a separable equation by using substitution z equals to x plus y, then obtain the solution. Okay, so now at first it is mentioned that dy dx equals to x plus y squared is not separable equation. So we need to show where we can reduce this to separable equation by using the right substitution. Okay. So now we have dy dx equals to x plus y squared. So directly you can show that this is non-separable equation. You cannot separate this x plus y squared. Even you expand, there is a mixture of variable there. So how can we reduce this to separable? We have to use the substitution given. So the substitution given is z equals to x plus y. And there is dy dx here. So you need to have dy dx from here. So first, you differentiate. Okay, differentiate z with respect to x. You have z dx equals to 1 plus dy dx. Okay, differentiate everything with respect to x because this one also with respect to x. So from here, we can have your dy dx, where dy dx equals to dz dx minus 1. So now, by using this, we just can substitute to here. So what your dy dx now is dz dx minus 1 equals to x plus y is z. Okay, rearrange dz dx equals to z squared plus 1. Now, is it separable equation or not?
Yes.
So, can you separate this? What is the separated version here?
1 over z square plus 1 dx dz equal to dx.
Okay, good. Equals to dx. So now, from here, you just can integrate both sides to find the solution. Okay, try to integrate this. What should you get? Integrate 1 over z square plus 1 should be trigonometric function there. Okay, recall back the integration techniques that you have learned.
Arctangent.
Okay, arctangent. So you should have here arctangent z equals to x, right?
Yes.
Okay, the original problem is given in terms of x and y, and the solution now is in terms of x and z. So just substitute back. What is that?
X plus Y.
Okay, x plus y equals to x plus c. So if you can just eliminate the inverse tangent here, we can write as x plus y equals to tangent x plus c. Right, it's just inverse process. So y equals to tangent x plus c minus with x. Okay, any question? So this is how you solve the non-separable differential equation and then reduce it to separable equation by using the substitution here. And once you can separate, you can find the solution. And again, you need to substitute back the original variable. That is how you do it. Okay, clear? All right, so now let's try this question. This is from passive question. Okay, try it first. The first one here. Okay, so the answer should be, I give you the answer, you can try. Try it now. I give you around 5 minutes. Apply the condition because the condition is given there. Okay, try it first. Okay, anyone has problem, you can ask. Done. All right, get it?
Yes.
Yes.
Okay, good. So I believe if some of you can do it, then the rest can do it. If you cannot do it, then you can ask your friend, okay? Because there's someone who can do it. So basically, everyone can do it, right? If you understand, how can we find the solution of separable equation? Okay, so that is for separable equation, okay? Okay, now let's proceed. You can try the rest of the question. If you want to know the answer, you can directly ask me for past year question in the notes. Okay. Okay. The next method is homogeneous equation. The next type of differential equation is homogeneous equation. Okay. So now, how can we identify the homogeneous equation? Okay. So are we ready to move on to the next types of differential equation here?
Yes.
Yes.
Okay, so how can we identify that equation is homogeneous? All right, so suppose we have differential equation, okay, which consists of function of x and y, then fxy is homogeneous if f lambda x lambda y equals to fxy for every real value of lambda. Okay, so how can we show that function is homogeneous? By substituting lambda x and lambda y in the function. And then if you can get the same exact function of f lambda x and lambda y equals to fxy, then you can say that function is homogeneous. Okay, so how can we do it? Okay, right? Now let's take a look at the first example of homogeneous equation. So this dy dx is actually a function of fx and y. Okay, so now your fxy equals to x squared plus y squared over x minus y, x plus y. So we need to show that f lambda x lambda y equals to fxy. Then we can conclude that the function is homogeneous equation. So what is f lambda x lambda y? So f lambda x lambda y, you just substitute x here with lambda x. So x squared now becomes lambda x squared. Y becomes lambda y squared over lambda x minus lambda y, lambda x plus lambda y. Okay, and then what you need to do is to simplify so that we can reach fxy or not. So this one is lambda squared x squared. Okay, this one is lambda. We can separate, we can factorize this. Right, so we have here lambda squared factorize. Lambda times lambda is lambda squared x plus y. So this one we can eliminate, and now it is fxy, right? So you can see here fxy, f lambda x lambda y is equals to fxy. Okay, after you do some simplification and factorization, again you get fxy. So if they are proven to be equal, then we can say the function is homogeneous equation. Understand? Any question? Okay, if you understand, why don't you try B? Is it homogeneous or not? Okay, try B. Just substitute, simplify in order to reach fxy. Okay, so Theo, get the answer already. It is non-homogeneous, right? All of you got non-homogeneous? Okay, so non-homogeneous also. Okay. No need to show, right? No need for me to show the step, right? I think you can do it. Okay, so can we just proceed?
Yes, can.
All right, so now that is how we identify the homogeneous differential equation. So how can we find the solution of homogeneous equation? Okay, there are steps here. So first, you need to determine whether the equation is homogeneous or not. So now we have done with how can we identify the homogeneity of the equation. And then we need to use the substitution. Okay, there is a specific substitution for homogeneous here. Okay, y equals to Vx. And then differentiate this, you get dy dx equals to v plus x dv dx. This is obtained by differentiate this vx by using product rule. So this is actually the substitution, and this one is the product of differentiation here. Okay, so we use substitution y equals to vx in the original differential equation. Separate the variable x and v, integrate both sides, and use initial condition. Once you use the substitution, it is actually the solution of separable equation. Okay, so let's try to do the example here. Okay, solve the homogeneous equation, right? So it is mentioned already. This is homogeneous equation, so no need to show. But now, how can we solve this? Okay, so first, why don't you try to separate this in terms of dy dx? Okay, so we should have here dy dx equals to, just put dy here to the right hand side, dy dx, then we have y squared plus xy over x squared. So this is homogeneous equation, no need to show. And then the next part is use the substitution. So the substitution is y equals to vx and dy dx equals to v plus x dv dx. So just substitute. Dy dx is v plus x dv dx and y is vx. Okay, and then simplify. We have here x square, we have here x square, we have here x square, right? So we just can eliminate this x square. So x dv dx equals to v squared plus v minus v. So what's left is v squared. Okay. By here, we can just separate the function equals to 1 over x dx. Then just integrate. So now this is the homogeneous equation. Okay. Apply the substitution. And then here you have to separate the function. And here integrate both sides. Okay. What is the product of integration here? What should you get?
Negative 1 over v equals to log s plus c.
Negative 1 over
1 over v
v equals to,
log s plus c.
all right. And again, the original problem is in terms of x and y, so just substitute back. So if y equals to vx, then v equals to y over x. So just substitute. Here you should have minus x over y ln x plus c. All right. So y equals to what? Y equals to minus x over ln x plus c. Right? Okay, everyone got it? There are no condition given, then we just stop up until general solution with C constant there. Is that clear, everyone?
Doctor,
Yes.
for the after the 1 over x integrate, the ln must compulsory put the modulus or can put the bracket.
This one? Right.
The ln x after the integration, we need to put the modulus or also can put the bracket.
Also can put the bracket because we don't want to solve the values here. We just want the function.
Okay, thank you, doctor.
If you put, it is also right. There is nothing wrong here. Okay? Any more question? So this is how you solve homogeneous equation. Okay, we have to use the substitution, apply the substitution, and then substitute back to the original variable. Okay, so from the notes given, okay, as you can see, non-homogeneous can also be reduced to homogeneous by using the right substitution. Okay, just like separable, if it is non-separable equation, then we can reduce to separable by using the right substitution. Same with this homogeneous. If it is non-homogeneous, by using the right substitution, we can reduce that non-homogeneous to homogeneous and solve the homogeneous equation by using the substitution for homogeneous. Okay, just like this example. As you can see, it is mentioned that the function given is non-homogeneous. Okay, but we can solve this non-homogeneous by using the right substitution where the substitution is given here. Okay, so now how can we find this? Okay, first you are given a substitution of x equals to x plus 3 and y equals to y plus 2. So here we have dx, the smaller x and the bigger x here equals to 1. dy equals to 1. So we want to substitute this dy and dx. So dx equals to dx, dy equals to dy. Actually, this is different variable. You can just use another variable so that you can see the difference. So now your dy is equals to actually dy. Your dx is now dx. Your y is y plus 2. minus 2. Your x is x plus 3, y is y plus 2 minus 5, which become y over x plus 3 plus 2 minus x plus y. So this is homogeneous. So from this non-homogeneous equation, by using the substitutions, we are now reduced to homogeneous equation. So this is homogeneous equation already, okay, by right. So you can show whether this is homogeneous or not by using the definition of homogeneity condition, where f lambda x lambda y equals to fxy. Okay, is that clear? So this is how you reduce non-homogeneous to homogeneous by using substitution. But if we want to solve the homogeneous equation here, we again need to use the substitution of homogeneous equation, where y equals to vx. Okay, and dy dx equals to v plus x dv dx. So again, you need to substitute. So dy dx is v plus x dv dx equals to y is vx. All right, okay, why don't you try? Try to solve this. Or you want to do this together? Okay, try first. Later I show you. So first, you have substitute the substitution for homogeneous. So what's next is try to simplify and then reduce to separable equation. Then you can solve this. Okay, I leave you about 5 minutes. Try to find the solution for this one. Okay, got it? Not yet finished? Okay, guys, done? Anyone has problem?
Yes, doctor, may you show the solution?
Okay, let's try to do this together. Then you can compare with the answer. Okay, so first, what is the simplified version of from variable x and b here? X divided x is equals to minus v squared over 1 plus v, right? So from here, you can simplify 1 plus v over v squared equals to minus 1 over x. Sorry. dv x. Integrate. Okay, it doesn't matter where you put the negative. So I just choose the simpler version of function to put the negative sign. Okay, to avoid the complicated calculation. So from here we have right. So this one can have here v this one. Slowly. Okay. So ln v minus 1 over v equals to this one is x. Right, we just simplify the logarithm here by putting the exponent in the right hand side. So we have exponent c, exponent 1 over v, where exponent to the power c is a constant. So we just simplify with a. Okay, so vx equals to ae 1 over v. Right, so substitute back. What is your v? V is y equals to vx, so v is y over x times with x, ae y over x, so x over y. So y equals to ae x over y. And remember, this x and y is actually from here. So from here, x equals to x minus 3, y equals to y minus 2. So substitute back. So y minus 2 equals to ae x minus 3 over y minus 2. So y equals to ae x minus 2 over y minus 2, sorry, x minus 3 plus with 2. So this is the final answer. Okay, so first you substitute, and then you use substitution, and then you simplify, and then you separate the function and integrate both sides. And this is the solution of v, in terms of v. And you substitute back what is your v. And again, there is another substitution of what is your y and x, and then simplify. This is the last answer. Okay. Okay, try to take a look first, compare answer, and then if you have question, you can ask. Okay.
Pardon, Doctor. Why e power c is equal to a?
Because c is a constant, right? So
Okay.
e is also a constant 2.8 something to the power of constant, which becomes another constant. So we just use a here in order to simplify.
Oh, okay, okay.
Okay, guys, done? Done and understand. So, okay, we have done with today's lectures. If you have question, you can ask, all right? And you can try the past year question in the notes. Okay. For homogeneous. All right, let me share you the notes first. Where is the question? Okay, you can try the separable equation. This is for separable equation. Okay, let me write down the answer for you to refer after this. The first one we have done, right? The first one we have done with this one. Okay, this is the first question. I just write down again the answer so you can check after this. All right, so this one is y minus ln y plus 1 equals to x squared over 2 minus 2. Second one equals to exponent x minus 2 x minus 1 squared plus 2. The third one set of y squared plus 1 equals to a over sine x. The fourth one should be okay, you can separate, you can simplify this one. And the last one okay, so this is for separable equation. Okay, and then for homogeneous, you can again refer this slide through the recording. I will attach the link of recording in the e-learning. This one you just can show, okay? Show first, how can you show? Okay, there is no answer for this. It just approving process. So you just need to show here. Okay, so for the second part, okay, so this one is the answer for past year question in the notes. And then for tutorial, the answer is given, you can try. Right now, it is up until, if you take a look at the tutorial, you can do it up until number, which number? Number 1 already done, right? Number 3, number 2 cannot because we don't have, we don't proceed with the linear. Can, okay, you can do number 3. Number 3. Okay, for tutorial, number 1 and number 3. Okay, and then the rest you can refer to the past year question in the notes. All right, so that's it for today. If you have any question, you just can directly ask me.